Let's now look at another problem like this with proportions. The first one on the top of the page there that shows, in the past 1% of all online credit card payments to a firm resulted in a chargeback where the customer refuses payment. The firm has introduced a new system in an attempt to reduce this percentage. What is the probability that less than 0.5% in a sample of 1,000 result in chargebacks if the new system changed nothing? Okay, if the new system changed nothing, then the past percentage of chargebacks still holds, and that's the 1%. Okay, so in this case, our population information is that P is 1%, which is 0.01, 1 in 100. Alright, now sample question, or our question essentially, is that what is the probability of less than 0.5%? Okay, so what's the probability that we get a sample proportion less than 0.5%? 0.5% is 0.005 in a sample of 1,000, where the true proportion is the same as before the new system, and that is 1%. Okay. Alright, so at this point we need to change that into a statement involving the mean and standard deviation of this approximately normal distribution. Okay, and so at this point we have to calculate that standard deviation, sigma sub p hat, which is square root of p 1 minus p on n. P is 1%, 1 minus p 99%, divided by the sample size 1000, and don't forget to take the square root of the whole thing. Alright, we'll now go to Excel to do that calculation. So equals the square root of p 0.01 times 1 minus p 0.99 divided by sample size of 1,000, and the answer to that is 003146. Alright, 3146, very small standard deviation. Alright, so now we have the statement in the particular normal distribution, and we have to change it into a problem involving the z so we can calculate these probabilities. Alright, so the past and assumed present population proportion, the mean of this distribution of sample proportion p hats is 1%. We want to find the probability that we get a sample proportion less than 0.5%, so it's the error in that lower tail there. Alright, we're going to translate that limit to a z value. Alright, the formula to do that, z is the limit p hat minus the mean of the distribution p divided by the standard deviation of this distribution, sigma sub p hat. So the limit 005 minus the mean 0.01 divided by the standard deviation 0.003146, if I remember, just to check. Right. Alright, we'll go to Excel to do that calculation. So it's 0.5%, 005 minus 1%, 0.01 divided by standard deviation, and we get minus 1.59 to 2 decimal places. So we find the probability of getting a z less than minus 1.59 on that z distribution is the same as finding the probability that we need. Okay, so what we're looking for is the probability of getting z less than negative 1.59. Yet again, it's an area in the tail, as you'll see with most of these. Not all of them, but most. So it's a half minus the area in the table from minus 1.59 through 0. And let's scroll down, minus 1.59 is that value there, 0.4441. The answer to that is 0.559. Okay, it's just above 5% probability. Alright, so what's the probability of if nothing happens, if the new system does nothing, that they still get a chargeback rate less than 0.5%, still about 5.6% in the parlance of the material that we'll do in hypothesis testing in 215. That's not significant, and so that 0.5% is still possible. Anyway, but in whatever way you want to look at this, it's not such a terribly low probability that this happens that it's totally out of the question. Alright, this video will end here, and the next video will look at sampling distributions with 2 samples.